Good evening and good morning, wherever you are listening from. It is a great honor for me to be presenting at this Prem Jain Distinguished Lecture Series on behalf of the International Center for Clean Water, which is an initiative of IIT Madras. I thank Dr. Hari for this opportunity. Dr. Hari is an inspiration with his energy and optimism. And I look forward to connecting with all of you in the future too. The topic given is tackling urban water crisis in India. And I would like to start by going back a few millennia. Okay, so civilization millennia ago centered around water. I think all of us know this. As you can see, the ancient four were centered around rivers. It shows how important water has been to humans since the dawn of civilization, how it was worshipped by people of those times, as Dr. Hari mentioned in the opening remarks, and India is still worshipped. So this is where we started from. And if you come to a few centuries back, in the past, even as recently as a few centuries ago, elaborate care was taken by citizens to conserve and manage water. These are some of the examples. There are several more. But somewhere, I think, since the advent of Industrial Revolution, probably, we humans have assumed that we can take charge of nature and probably gone a little berserk. The truth is that we are very much a part of nature and everything associated with it. Every time we take advantage of nature for our benefit, it hits back sooner or later. So hence my attempt here is to portray a strategic direction for water management for cities, urban cities, but it could apply elsewhere too, that aligns with nature, takes advantage of nature, respects nature, and hence with minimum effort, I think we could get maximum benefits. Because if nature is working for us, why would we work against it and complicate our lives? So cut to today, this is an oft repeated picture. I'm sure most of you have seen various versions of it, but I see something positive in this. This is the situation in any city in India. During the floods, during the monsoon, there is floods, and then there's water scarcity soon after. But what does it mean? There is abundance of water. That's what I'm seeing here. There's huge water available, but poor management is the problem. And the only source of water in most Indian cities is rainwater, unless you are close to the Himalayas. But it is more than abundantly available. But what we are doing is we are wasting it. So I think with this context, I would like to go forward. Where did we go wrong and why did we end up like this? One of the things is depletion of groundwater, because we do not have a plan for capturing the only source of clean water, which is rain, and preserving it for our future use. This is not a technology problem. It's a thinking problem or a mindset problem. Otherwise, why will we build pavements that do not allow water to percolate, but allow it to run off into lakes, rivers, or the sea? And if the runoff were to be a clean river or lake, it's okay. But our lakes and rivers are polluted. And this rainwater runs there and gets polluted also. So this is what we are doing. We are allowing fresh water to fall down, clean and pure water, run off onto the lakes and rivers, or water bodies, where we pollute them with solid waste and liquid waste and whatnot. And we are therefore drawing more and more of groundwater to sustain ourselves. And our dependence on groundwater is increasing, which means it is depleting. It is not being recharged, as we just saw before. So we're going deeper and deeper to fetch fresh water, where we will find the life-threatening contaminants, whether it's fluoride, arsenic, maybe even uranium is found today and other heavy metals. So this is on one side, the problem we have created. And also, we have tried to fix the solution by corrective actions, like reverse osmosis. I think that's more a corrective action than a preventive action, because it takes care of what we drink, but it does not take care of what we discard. So over the decades, RO, though it's a fantastic technology for providing clean water and it has saved several lives, but it has inadvertently added to the significant deterioration of groundwater quality. So this is the scenario that we are facing today. But as I said before, I see a huge opportunity, the water cycle. See, unlike fossil energy, water is a naturally renewable resource. It is getting renewed every day as we live, as we speak. All we need to do is not allow it to run off into the sea and then spend big money on desalination plants. I think it's silly, if you ask me. So even a city like Chennai, I think it is in the world map as one of the water stressed cities. And recent times it has faced severe problems even 2 years ago. But if you do a quick back of the envelope calculation, what you see is for the area that it has and the annual rainfall that it receives, it is getting far more water than it needs. The demand is even 70% or 80% of what it receives on an average. So somewhere something is missing. There is abundance, and that is something we need to keep in mind. Most people talk of water conservation, and I think even Dr. Usha had talked about water conservation. Yes, all of us must conserve and use less water. But I think that if we manage water well, there is plenty available for us, and we can all be a little bit more liberal in its use. And that's what I'm looking forward to. So this is something that I wanted to share. And I see things happening, as Usha mentioned, community participation is the key. Because in the 2.5 years, ICCW is a young organization, and my association with water intensely has been only from ICCW. Prior to that, I was doing several other things. But what it has taught me is that our water management is in silos. Though with the Ministry of Jal Shakti, now things are breaking down and becoming unified. But still, at lower levels, we are working as silos, and therefore we are unable to see the bigger picture. But I see many good things happening in my neighborhood. This picture in the left is happening just around where I live. There are citizens who are coming out every Sunday and planting trees or plants or whatever. And they've done fantastic work. And it made a difference in the society and to the water quality and the water table. And if you go all the way down, you see Mysuru is one of the cleanest cities in India. It's green. So what we are missing out is how do we make water percolate? And can we have greenery? Can we build up pavements and various other infrastructure to receive water directly and take it to the ground, replenish it so that we can use it in the future? If not, at least depending on the aquifers, it can even run off to catchment areas from where we could draw it. But those catchment areas must be kept clean and free from pollution. So, typically rainwater harvesting is what is talked about. It is the only way by which we can capture water, because as I said before, rain is the only source of water for us. Groundwater is only a reflection of what is received from the rains. So can we commit ourselves to nurture the only source of clean water for most of humanity, something that is so generously replenished every year by nature? Capturing and retaining rain, whether in aquifers or in surface catchments, must be done everywhere. Our ancestors have taught us that. As we saw before, there are fantastic systems that they have created. Can we give a scientific validation to all of them? The step wells, the Johads, the Aries in the south, all of them have a scientific basis. If we can do that in ICCW with IIT Madras, we're looking at how do we validate these things? How do we bring it into a curriculum of every student today, whether it's in school or college, and a separate elective subject for engineers, so that when they pass out, they are very much aware of what to do and what are the do's and don'ts, and are also equipped with the know-how of how to do it, and also learn from the past. So this is something that I see as a great promise. Alternately, Mr. Indukant Ragade, he was there in the call, in the talk 2 days ago. He's done phenomenal amount of work in Chennai as part of Alacrity Foundations, where it's very, very simple, low-cost techniques of recycling greywater. Greywater is water that comes out from our sinks, showers, and washing machines and can easily be separated and recycled. It's 95% clean water. And there is no need at all to send it to sewage treatment plants, but we are doing that. So, and we are overloading the sewage treatment plant, making it mostly inefficient and losing huge amount of clean water in the process. So just a bypass, just a T-valve, take it to the ground, have these Cana indica plants, and nature will do the trick. It will send it to the ground clean and we can reuse it. And unlike rainwater, greywater is available around the year. 12 months a year, you have greywater coming out. So there's no seasonality there. Reuse is something that many citizens are practicing today because they have been forced into a corner on many occasions. RO reject water is being used, and I think it's a good idea. It should be used as appropriate. but there has to be some knowledge, and because it can cause some degradation of property if the high salt content is used to clean certain parts of the where we are living. And this will, but it's a good idea to do it in a more knowledgeable way, and many citizens are already doing this. Reduce is another one which, as I said before, reduce doesn't mean compromising on cleaning efficiency or losing out on some performance. There are water faucets available today. Technology has gone far enough to trap ambient air and send it as a jet. So 90% of the force is air and 10% is water. And that force is enough to clean. So with 10% of water, we are able to clean more effectively than 100% water. And moreover, there are also systems which come with ozone instead of air, which may be a little expensive, but that can disinfect also, which means you don't need to use soaps. And with clean water, you could disinfect, and therefore the grey water becomes easier to recycle. So these are some of the thoughts I want to leave with the people. I will touch upon some more technologies, which we can come back to as we go along. So this is very, very low tech, but I mean, low cost. I would not say low tech, low cost, and easily doable projects that I've listed here. We can look at some little more higher end technology which can make a difference. One of them is an incubated company here, which is doing capacitive deionization. What it does is simply use electrodes to remove ions. And in the process, we're able to retain what we want to retain, those ions, which are calcium, magnesium maybe, and reject those which are harmful. All this is done with very little energy usage, and this unit itself has a very long life. But it has a certain limitation today in the amount of dissolved salts, and it can handle. So there is some R&D that is required. However, it's phenomenally been successful in the villages, and we are looking to bring it to cities where instead of RO water, where for every 1,000 liters, we may need to draw 3,000 liters. Here, 1,000 liters of raw water is sufficient for the same output. And as I said before, it runs on very low power, so it can be entirely run on solar and very easy to maintain by anybody. And as it retains minerals, it's also healthier to drink. So this is one technology that's available for city dwellers to improve their water quality. And there is another emerging technology which is even more exciting, which is called dealkalizer. We all suffer from hard water, which has temporary hardness as well as permanent hardness. So alkalinity is the term used to measure the hardness in the water. So typically alkalinity is removed by ion exchange resin, but ion exchange substitutes calcium with sodium possibly. So the TDS, the dissolved salts, don't change. This technology replaces calcium with hydrogen. And therefore you don't have, your TDS comes down. And so what it does is it not only removes hardness, at the same time it reduces the dissolved salt. This allows us to develop a beautiful solution, which I've shown here. You take raw water currently, you put it to a storage tank, you do your pre-treatment, sedimentation, carbon filter, etc., put it to a tank, run the dealkalizer. What it does, it removes hardness completely and also reduces TDS. Now you run it to a low pressure RO. It's not a high pressure RO, extremely low pressure RO, which will reject 90%. And 10% will pass through, which is excellent water for drinking, which is probably what the people would like to consume. 10% of all the water is consumed for drinking or cooking. And the 90% reject actually goes back to the tank. And because it is all pre-treated, so it can go here and it can again complete the loop. So therefore, there is zero reject of the RO. And plus you have clean drinking water. And the rest of the usage, this water it need not 100% go here. It can also go for washing and other applications, which is soft water, which is what they look for. So we see a huge opportunity to develop these kind of technologies in the future. Now, another one I want to touch upon is using nanotechnology, which is for removing heavy metals, where you don't again need to waste water. As you can see, nanomaterials have very high surface area. So they have a very high absorption capacity of the metal that they are absorbing, and they last for several years. And because of their ease with which they absorb, there is no pressure required as the water flows across them. So which means from 10 liters per day to 1 million liters per day, this system will work. There's no power required. It works with gravity. As I said, the media lasts for several years. The cost is not even 2.5 paise per liter, much less than 3 paise. 1 paisa is less than 1/100th of a rupee, is exactly 1/100th of a rupee. And there is no wastage of water other than the back flushing we do. And the media itself keeps the arsenic, hangs on to it tightly. So even if you were to dispose after 2 years, it will not leach out and will not recontaminate the ground level. So this is another technology that I think is available for people in those parts of the world where arsenic and heavy metals are contaminating. Atmospheric water generation is not new, but there are continual improvements taking place in the energy consumption, because that is where it is making a difference today. I would say just a single breakthrough away from eradicating drinking water problems for the whole world. In one stroke, it can eradicate the drinking water problem, because huge amount, trillions of liters are there. All it needs is how to figure out a low-cost way of converting it. We have a high-cost way of doing it today. But the beauty of the system is it produces water at the point of use. You don't need to transport it. So no diesel required for transportation, no packaging required, and there's no wastage. So, and there is no footprint. I mean, the water footprint is negative. I've said positive, whichever way you look at it. It's not depleting ground or surface water. So this is available today as a product. Now going on to water, which is used water. People don't call it wastewater because that gives a connotation that you can waste it. The terminology used by even the Tamil Nadu government is used water. So STP is one major headache in most parts of the country, because whatever designs are there today, they have certain limitations in terms of maintenance that has to go into it. And with poor maintenance, it deteriorates and it becomes a vicious cycle. New technology, these are startups. STP is a Bangalore-based company. So they have used biomimicry by using understanding of what's happening inside a cow, which has 4 stomach parts. And this has no moving parts at all, can be kept completely underground. It requires no maintenance, and it's odor-free, 0 operating cost. It's an elegant system. There are several such. I'm just picking up one to show that these are available, and these can be introduced into our cities. There may be a little capex, which is on the higher side, but everything is not easy. So there is some cost benefit that has to be considered. Similar technologies are there, which are circular economy. Another wow is taking wealth out of waste. So we have startups, students who have yet to pass out, or some of them just passed out, taking urine and converting it to fertilizer and giving the clean water back for the maintenance of public toilets. So this is a brilliant suggestion which pays for itself. There's no need for anybody to invest. Even the person employed there can get paid. Similarly, there are what they call toilet to tap treatments of STP water, which can go all the way. And I'm sure Israel and Singapore are doing it. In India, it's a mindset issue. But at industry level or the various other opportunity areas are there where such technologies can be put to use. So we have covered a range of technologies for clean and recycled water. What I want to talk about now is how do we empower citizens, involve them, and get them to participate. One of the things that we at ICCW are doing is developing extremely low-cost sensors. And we are empowering citizens to take responsibility and leadership, because we are giving them the charge. We are saying, take these sensors, go to the field or wherever you live, collect the samples, you put it into this device. It will instantly give you about 7 parameters today. It can go to 12 parameters, which gets onto the mobile phone, and it gets loaded in a jiffy onto the cloud, and instantly and accurately. So what we are doing is not only getting citizens to contribute to measurement of water quality, they are also getting educated about what is the situation around them. And they're helping populate a cloud database, which can then be subjected to data analytics for prediction, for measuring the evolution of contaminants and what will happen in the future, and so on and so forth. So the huge wealth of information can come with very minimal cost and with the benefit of educating people as well. We've started this in Chennai city. College students have actively taken part, and it's an ongoing exercise. So this is an area where I think collective involvement of people can be brought about. And thereafter, once they are involved and they are aware of what's happening, I don't think we can stop them from doing what is needed to be done. So taking this forward, there are more exciting technologies, the next generation which is evolving, because You don't even need to contact the water. You just point a camera at it or a mobile phone at it, and spectroscopic instruments are able to detect. Obviously, it requires a lot of data science to see each image may have a fingerprint of a particular type of contaminant or a set of contaminants. So once we create all these fingerprints and we are able to map them to contaminants by cross-checking, tomorrow you can put that device into a faucet, and as the water flows, you get the real-time feedback of water quality. You could create a water pen, because the Jal Jeevan mission today is looking at connecting functional taps to every household. Still, people will need to be reassured that the water quality that they get is fit to drink. So a simple pen-like device is possible today, where a green light will say you can drink the water, and the red light means you can't drink the water. What it will mean is it just measures three things: pH, TDS, and chlorine, residual chlorine. Because anything, once it's treated, what can go wrong is bacteria contamination, some changes pH because of some leakage or some mixing which is happening in the pipelines, or TDS can go up. If these three things are within control, I'm sure this pen can be made available at a low cost of 5 rupees or 10 rupees or even 100 rupees. We don't know. We haven't yet fixed a price on it. We believe that it will have a phenomenal advantage in educating our people and protecting their lives or their health. Similarly, a laboratory now is a mobile lab. Anybody who is wanting to service a water treatment plant or a water filter has to take this a small case. It's like a vanity case. It has a pipe, plug it to a tap, and instantly readings are coming. I just wanted to share a few ideas as to where we are going with technology in terms of monitoring water quality, and which will mean that in the future, it will lead to some kind of a digital twin of cities or smaller townships, or even an apartment complex, or even an equipment or a STP or an ETP. There are many startups in the space, and they are picking up this information. They are using analytics and machine learning to optimize the life of the equipment, minimize the maintenance costs, improve the product output quality. And so this is where things are going. And I think it's exciting time. We can all be part of this. Data will flow like water. This is what we are believing. And data will be water. So whichever way we look at it, data plus water will become the new norm for water management. And so this is how cities will then benefit. Smart cities are already looking into it in different ways. And I know that many companies are working towards this kind of dashboards for the stakeholders. So eventually, this is my dream I wanted to share, is that water is life, and we must have the luxury to enjoy life by using as much water as we want, knowing full well that we have taken care of its future availability and quality in a sustainable way. And in this, nature's help is guaranteed. So if it is possible for us to enjoy a shower without worrying about how much water I'm wasting, today we are nowhere near that. Hopefully this day is not far off. Thank you very much once again for your